Were you able to finish that up before class? Or gonna be able to finish that up before class? Good morning, folks. Happy Friday. Who are we missing? So when I've started talking, thank you. Who are we missing today? We're missing three. So, all right, James, of course. Brennan, who sits next to you? Ryan. And Darren. Okay, hopefully they'll be here soon. We got stuff to do. I think James won't be here, but yeah. Hey, Ryan won't be here either. Okay. So I'm gonna have you sit next to Brandon for today, please. Are you able to see the date from where you are? Kinda. Here we have a, for those of you who can't see it, it looks something like a 60-degree angle here, and it says that this is 6. Is this difficult to know that this is 12, or is that pretty fast for you at this point? Okay, so today we're going to be doing a little review of 36 and 90 triangles as well as 45, 45, 90s. So just remember, in any 36 and 90 triangle, this is A, the hypotenuse is 2A, and the longer leg is A root 3. Whereas for the 45, 45, 90, the legs are the same. I'm going to call both of them A, and the hypotenuse is A root 2. So I know that you've been doing this a little bit. This chapter, we're just going to hammer it in a little bit. Okay, so number 1, does it make sense? Numbers 1 through 9 refer to a 45, 45, 90 triangle. So if we know that A is 4, do we know B? It's also 4, and C? 4 root 2. And that's what you're doing. We're going to fill these out as quickly and efficiently as possible. Once you finish number 5, check in with your neighbor, make sure it's going okay. Did anyone already finish number 5? It's a couple of you. Okay, it looks like everyone got that. I'd like to know how you did number 5. You can explain what they did. Or some advice maybe to someone who might be struggling. Because 5 is where it start getting a little bit weird, wasn't it? It's like you're flowing. And then 5 came out. So how do you do 5? Yes, Lily.
Multiply by root 2 over 2, which would give you 6 root 2 over 2, which is just 3 root 2.
Are we good with that? I really like how you say you just divide by square root of 2. We know that when you're going from, okay, everyone's attention this minute. We're going from here to here, you multiply by square root of 2. So if you're going from here to here, just divide by square root of 2 and work that out. One quick way I like to rationalize fractions or rationalize denominators like this. I think about 6 as 3 times 2. And then I know that 2 is root 2 times root 2. So I just kind of cancel them. Another way to think about that, if you like. But really what you did is perfect. I'm gonna give you a chance to finish. Has anyone gotten up to 12 already? Has anyone finished? Take a couple more minutes. Check in with your neighbor, just make sure everything's going okay. I'm gonna start calling on, everyone's gonna be called on at least once today. Because I got 2 through 18, I got 17 questions, so there's only like 12 of you today. There's 11 of you. Take another minute. If you and your neighbor are struggling, maybe get some help from the person in front of you, behind you, tips, tricks. You say like, how did you go so fast? Someone who's already finished. Okay. Now, when I call on you, I want 2 numbers. Just whatever ones are blank. I want those numbers. I don't want you to say like A is this, B is that. I just want the 2 numbers. For instance, Ava, can you tell us your answers for number 2, please?
And 2, 2.
For number 2? Oh yeah, 2/3. And what? 2 roots 2 over 3. And thank you very much. By the way, this is correct, but if you see a wrong answer up here, please don't say anything. Priscilla, number 3. Thank you. Number 4. Sasha. Okay, thank you. Sienna. I feel like you need to do another one. Root 7, root 7. Thank you very much. Ivy. Thank you. Mia. 2.5 and 2.5 root 2, you said? 2.5 root 2. Okay, thank you. Emma. Thank you so much. Are we good with these? Are they all correct? Of course, 2.5 root 2 could also be rewritten, or could also be written as what is it? 5 root 2 over 2. Cool. Let's move on to the next set. Number 10, Chloe. Thank you. Lily, number 11, please. Brandon.
I got 5 and 10.
Thank you. Dylan, number 13. 2, 3, and 4, 3, you said? Okay, thank you. Number 14, Sienna. 15, Chloe. 6.5 and 6.5 root 3, you said? Okay, thank you. Number 16, Emma. Thank you. Dylan, 17. And finally, Ivy. And what? 3 over 2. Any questions? Are we good with these? Comfortable? Excellent. Okay, these, you may be wondering, is it Taco Tuesday or something? No, it is not. These are not tacos. These are half pizzas. It's Pizza Friday. And it's your job to cut these into perfect slices. Even slices, or the customers will be mad if they get a small one, right? I feel cheated. This first one, I want you to cut into 2 slices. Second one, I want you to cut into 3. Next one, 4, and then one after that, 6. Do a good job. Get it right. Remember, we want all the pieces to be the same size. Oh, yeah, these are all terrible. These are awful. I feel ashamed of it. Some of your work, this is just shameful. Not good at all. So for the first one, can you please show me your slice? It's just right down that middle, isn't it? Be nice if we had a center point, wouldn't it? A midpoint of the end there. Okay, for 3, can you show me your cuts? It's a nice V, isn't it? I feel like I missed the center there. Something like that. Would anyone be disappointed in one of the slices if it were cut like that? I would be pretty happy. It's just like, why is it so wobbly? What's wrong with you? Number 4 slices. The first cut we're gonna make is probably easiest to cut in half, right? That's, and from there, cut the same as we did for 3. Really? Is it the same places? It's not quite the same. For 3, it was like here. For 4, it's gonna be more like here, won't it? Make it nice and even. Okay, for 6, the first one I should cut is, I cut it in half, make this easier. Yeah, I definitely missed that middle. And from there, cut each one into 3 slices. So would this be a good one to start with? I did a pretty good approximation. Now, I accidentally cut it in half. That's not going to work, is it? Like I could do 3 slices then, but one person will be very happy, 2 will be very sad. I want it even, I gotta do something like this, don't you think? Yeah. Okay. Let's keep going. Oh, look, it's a full pizza. Could you please cut this one into 8 slices? And cut this one into 12 slices. Check with the neighbor. Make sure that they will not be fired from this job. They look pretty even. What could be adjusted? Analyze your own. I know this is hard. I don't have straight edges for you. I see. See you doing your best. See some really good results. Let's see if I can make this happen. Okay, does yours look something like this? Okay, let's talk about degrees, shall we? We're going to start going around these pizzas, starting from where? Where do you think we're going to begin our journey? This way, aren't we? It always begins here. So like this is 0 degrees. The next one is going around right here. 45, isn't it? Keep on going. Did I do it right so far? Up to 180 degrees. I need some help going all the rest of the way around. Priscilla, can you help me, please?
I put 225 actually,
Okay.
and then 270. And then 3.
Do we agree? Cool. Did you already do the next one? If you haven't, go ahead and finish it. 0 for you. That's it. I know this is like the hardest one we've done all year, isn't it? So challenging. Brandon, could you read me the degrees all the way around, please?
30, 60, 90,
Wait, before you move on, do we agree so far? Okay, I'm going.
120, 150, 180, 210, 240, 270, 300, and 330.
300 and 330. Of course, this is accurate only if the slices are perfectly even. And they are, because we want everyone to be happy. So things are good. Any questions? No, of course, it's easy stuff. Okay, we're gonna go back here and do the same thing, except instead of degrees, we're gonna do radians. I know that this is 0 radians. I know that if I go all the way around, not all the way, but to the other side of the pizza, it would be pi, wouldn't it? Does it make sense that straight up would be pi over 2? Does that make sense? Because that pi is being cut into 2 slices, so we have pi over 2 and pi. Do the same thing in the next one. We have 0 over here. I know that this is pi, but each one of those cuts, do you see what the first one would be? Check with your neighbor. What would be a good radian measure to put right here? What is it? Does it make sense, pi over 3? Without doing any like multiplying by pi over 180 or anything like that. This is pi over 3. If that's pi over 3, the next one's going to be, by counting, I hope it makes sense that that's 2 pi over 3. 1 pi over 3, 2 pi over 3, 3 pi over 3. Here's this pi. Do you do the remaining slices? I'll do 0 and pi for both of them. Check with the neighbor, make sure they're following along, okay? Okay, so the 4th slice, you ready to be called on? Mia, could you help me with 4 slices? How did you get that 3 pi over 4? Are we good with that? That's what I'm hoping for. And the pi over 2, did that also come from counting? Are we always supposed to simplify fractions? Yeah. So thank you for doing that. But really it comes down to 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. The next one. Ava. How did you do these? Like, I understand the pi over 6, but how about the pi over 3? And then pi over 2 came from. Are we good with that? Just counting. No big deal. Thank you, Ava. So now that we have those, let's do both of these. And instead of degrees, or right next to the degrees, we'll do radians. All the way around. So right here, when you write 45 degrees, that's the same thing as pi over 4, right? Pi over 4 goes there. And just keep going. Did you get it? Let's do the 8 slice. Lily, can you tell us what you got for the rest?
And then 5, 3 pi over 4. And then at 185. And then at 245, 5 pi over 4.
Okay, before you go on, are we good with that 5 pi over 4? Does that make sense? Does 5 pi over 4 make sense, everyone? Can you do some crazy calculations to get there? Okay, keep on going.
And then 3 pi over 2. Oh, and then 7 pi over 4.
And if we were to keep going, 0 could also be written as 2 pi. Does that make sense? Could we keep going from there after 2 pi? What would the next logical number be after 2 pi? Well, check with your neighbor. What would the next logical number be after 2 pi in the same circle? I want to hear it on the count of 3. 1, 2, 3. Are we good with 9 pi over 4? So 9 pi over 4 is coterminal with pi over 4. After 9 pi over 4 would be 10 pi over 4, which of course quickly drops to 5 pi over 2. So 10 pi over 4, 11 pi over 12, 12 pi over 4, 13. It's just counting around and around, where the angles don't stop. It just keep coming at you. Has anyone already done this one, the 12 slice one? You overachievers. Everyone catch up to those overachievers. You already finished? Get back, relax. The rest of us. That's a nice way to keep reading. More comfortable. Did you get it? All of them, are they right? Are they simplified? Do they match any of the ones before? Is there any in common? Did they match? Whose is this? Anyone know whose this is? Sasha, you know. Only one who hasn't been called on twice. Sasha, can you help us out with this? I know that 0 degrees is the same thing as 0 radians. That's all I know right now. Five or six, you said? Okay. And before you go on, are we good so far? You're clear to continue. Two pi. Thank you. Can we continue going from 2 pi? Check with your neighbor. What's the next one after 2 pi? On a count of 3, let's hear it. 1, 2, 3. 13, 5, or 6, etc., etc., etc. Okay. Just wait for you. Cool. Let's keep going. Do you know what circles these are called? Well, as it is, they're just called circles with slices. But in this class, one big math tool is the special circle called the unit circle. You've heard of this? What's special about a unit circle that sets it apart from other circles? Do you know? Well, check with your neighbor. Do you have any idea? Have you heard whispers in the wind? What is a unit circle? Yeah. Anyone know? What's special about the unit circle? What makes it fancier than all the other circles? Anyone have any idea? Lily, what's that?
I don't,
What you said is
just speculate.
it's a good speculation. What was your speculation?
How the radius.
It has a radius of 1. That's it. So it's unit circle. So if these are unit circles, the next exercise I'm going to ask you to do is to find the coordinates of the endpoints of each one of your slices, if the middle is at the origin. For instance, 0 degrees. That point right there would be what, comma, what? Hold it up if you know it. 1, comma, 0, right? If the radius is 1, then wouldn't this be 1, comma, 0? Do you know any other coordinates? Meditating on this, thinking deeply. For coordinates, any other point, any other points easier. We're just working on the 8 slice one for now. Were you able to get any other coordinates? Hopefully you got 90 degrees, right? 90 degrees coordinates are 0, 1. At 180 degrees, they are -1, 0. 270 degrees, they are, oh, that's getting so crowded there. But I can fit in 0, -1. Okay. Those are pretty easy. Now for pi over 4, some people might say it's 1, comma 1. What do you think? Those people might be a little bit misguided. It's 1, comma 1 would be in the right direction, wouldn't it? But it's not a point on the unit circle. Were you able to get the coordinates of one of that 5 or 4? Check with your neighbor. If you and your neighbor can't figure it out, check with people around you.
Okay, if you draw them right here, that's. Oh,
Okay. Did any of you get it? I think some of you haven't. Maybe you're being a little bit shy about it, and that's fine. I want to talk you through it. This comes down to, Sasha, make sure you're paying attention here. If we're looking for coordinates, remember to get there, we start at the origin, don't we? Start at the origin and then we travel along the x-axis until we get to right under it, and then we go right up. It's got to go directly up. And I just made a triangle, didn't I? 45, 45, 90. Bless you. I get excited and sneeze when I see 45, 45, 90 triangle sometimes too. Do I know any of the sides of this 45, 45, 90 triangle? The radius of the circle is 1. So does that translate to the triangle? Quite nicely. We know that radius is 1. So do you know the other sides? I think you did this problem today. Didn't you? Number 9. The other sides are √2/2 and √2/2, which means the coordinates at that point would be, I'm going to go back to black here. I'll write this down here, √2/2, √2/2. So the coordinates are √2/2, comma, √2/2. What do you think? That makes sense? Do the rest, the 8 slices and the 12 slices. Be calling him maybe everybody. Can I get help with 30 degrees from someone? The coordinates of 30 degrees. Any volunteers for that one? I'll give you a moment. Okay, I'd like some help with 30 degrees, please. Who can help me? Okay, I'll help me. Crazy kid, start at the origin, go along the x-axis, and then go right up. What kind of triangle do we have here? You sure it's 30, 60, 90? It better be 30, 60, 90, or those customers will be very unhappy with their slice. This is 30 degrees right there. And do we know any of the sides of this triangle? Yeah, the hypotenuse is 1. That's how we know that the short leg is 1/2, and the long leg is √3/2. I think it was Emma who told us those values in number 18. Wasn't it? I think I remember your voice kind of rings in my mind. Maybe. So the coordinates of that point at pi/6, the coordinates are √3/2, comma, 1/2. Now, if your slices are jacked up, if that 30 degrees looks big, remember, opposite from the 30 degrees is always the short side, whatever it is. That has to be half of that hypotenuse. That's right, 1/2. 60 degrees, was it difficult to do? Or just take the triangle and do some rotation? I'll be calling this one in just a minute or so to help with the rest of the 8 slices. And then I need someone to help with the 12 slices. I think I'll just call one person for each one. Are we ready? Ava, can you help me with finish the rest of the 8 slices? I think I just need 3 more. So far we did 45 degrees, we did 90 degrees.
√2/2, √2/2.
Okay.
And then the last one is √2/2 and then
Now, how did you know that is positive and then negative? Exactly, because you know how to graph, I imagine. Are we good with those values? Nicely done, Ava. Thank you. I'll get Yvonne. Yes, Mia. But yes, you can say the degree and then the coordinates or something like that. Okay, before we continue, are we good with that? Same triangle, just instead of lying down and standing up. Okay, keep on going. They're both positive there? Okay. No problem. Cool. Are you sure they're both negative? You're certain? To speak the truth? Okay, keep on going. Thank you so much. Any questions? Have any of you done this before? Hope it was comfortable. If we had a quiz on this next time, do you think you'd be okay? The degrees, the radians, and the coordinates? Just curious. I didn't give you 3 minutes to work out anything that you not. Oh, do you want to grab a drink while you have a break?
That's not. It's not stupid as that. That's what it was.
Okay. Let us continue. When I say let us continue, what I mean is break is over. You two need to be a little separated, don't you? Shannon and Sasha, I feel like I have a hard time getting started. The conversation continues. You miss the hint. That's okay. I know you're involved in the conversation. So have you seen that thing on the board that's been up all year? You know what that is, right? Is it making sense now? Like what's going on? It really annoys people that the slices are not even. What do you think about that? Are they really not even? Like some people are just dying. Come up and if they could, just take this point and move it right over there. So that everything would be even, but I think those people might be missing the point, don't you think? Really, that all that is the two different types of pizzas superimposed on one another. So do you all see the 8 slices and the 12 slices all together? It's not like a 16 slice pizza. So everything's going on there. So the question is, what's so important about the unit circle? What's helpful about it? Well, and I'll tell you what it is. It puts the values of sine and cosine at your fingertips very quickly. Remember that sine, I don't know if you have room to write on your paper. You might have to spill over into your notes somewhere. Sine theta is equal to what over what? Not with SOHCAHTOA, but with what we did the last couple times. The letter over a letter. Y over R, isn't it? And cosine of theta is equal to X over R. And what's special about the unit circle? The radius is 1. So what's going to happen to both of these fractions if the radius is 1? Yeah, it's just the X or the Y. So for the unit circle, and this is what you need to write at the top, in the coordinates, the first value is the cosine theta. Second value is sine of theta. That's the hugest thing about the unit circle. Once you have all your values, the first value is the cosine of that angle. The second one is the sine of that angle. There's no need to evaluate triangles or where they are. If you know the points, you are done. In other words, if I'm looking for the cosine of 5 pi over 6, you all see what the 5 pi over 6 is? Cosine of 5 pi over 6? Negative 3 over 2. I want to know the sine of 2 pi over 3. Here's 2 pi over 3. It's up there. Sine of 2 pi over 3. That's not. It's over here. This is 2 pi over 3. Sine of 2 pi over 3 is 3 over 2. Remember which is which, I recommend thinking, because some people get confused about which is cosine, which is sine. It's alphabetical order. Cosine is the X value, sine is the Y value. So let's go back to the packet. And last we worked on the packet, we were working on these problems. And it was difficult. It was pretty annoying too. Let's do these in the context of the unit circle though. Sine of 135. You may want to actually have the work that you did today out so you can reference it quickly. 135 is right here. So what is it? We're doing sine of 135. The positive or negative? Where it's cosine and then sine. It's a Y value. Positive root 2 over 2, isn't it? Just like we had last time. Cosine of 4 pi over 3, we don't have to go through this. Cosine of 4 pi over 3 from your unit circle, do you see it? The negative 1/2. On your unit, do you see it? Circle. It's much nicer, don't you think? But how are you going to get like this is tangent? How do you do tangent of 14 pi over 3? Well, first let's find 14 pi over 3. Yeah, do you have an answer or question?
With having.
Oh, discuss for just a moment. Yes, 14 pi, tangent of 14 pi/3. Find where it is and how you find the tangent of it. Okay, so tangent of 14 pi/3. Well, first of all, where is 14 pi/3? Could you please point in that direction? Please point in that direction with your pen or your finger or your arm, your body. Check around, make sure everyone's pointing the same direction you are. So this way, how do we know that? We started 0 pi/3. 6 pi/3, does that make sense? You do that? And then you went to 12 pi/3, 13, 14. Does that sound like maybe something you went through? So 14 pi/3 would be the same thing as 2 pi/3, is that right? So we're looking at this. How would you get tangent from that? Cassiana, do you have an idea?
Side is why that's gonna be why. And cosine is that. If you sine of the cosine, it's y graph.
Yes. Perfect. Yeah, we know tangent of theta, I think it said is equal to y/x, not depending on r. We know that y is sine, we know that r x is cosine, so I love how you did that. So this is sine theta or cosine theta. Did you get a value? Do we agree? -√3? I'll check it. I'm not sure. I'm looking at this is the y. We have √3/2 over -1/2. Instead of dividing by -1/2, we can multiply by 2, or just cancel those denominators, or multiply through top and bottom by 2. We have -√3. Nicely done. Any questions? How would you get cosecant of theta, secant theta, and cotangent theta? Cosecant theta is from the unit circle. Cosecant comes from sine, isn't it? Instead of y/1, it's going to be 1/y. Secant, 1/x, and cotangent is not y/x. x/y. I think these are all in your packets. It should be in your packet somewhere. Let's see down here. This is, okay, we can write this here. So sine of t, that is equal to y. Cosine of t is equal to x. Tangent is y/x. Cosecant, 1/y, 1/x, and x/y. In terms of unit circle, that's always how to get these values. Oh, I'm sorry. Here you go. This should be in your notes. So here they're calling it the angle T instead of theta, which is common. Ooh, sine of 90. Did you do that for the unit circle? Refer to your work from today. Thank your neighbor about sine of 90. Show me your answer for sine of 90. Are you good with just one? Because you took the y coordinate. Yeah, whatever. Yeah. Can you show me the cosine of 3 pi over 2? It is 0. Nice. We're able to get tangent of 0. Also 0. How about secant of pi over 2? Now be careful with this. Secant is defined as the reciprocal of cosine. So this is going to be, does it make sense that I've made this so sketchy for all these problems? What kind of angles are these called, by the way? Quadrantal angles. Okay, so if I'm looking for secant of pi over 2, I'm going to look directly up. I'm going to look at which value, x or y? X, because we're going to reference a cosine. But it's not going to be 0. It's going to be 1 over 0, right? It's 1 over that x value. 1 over 0 is equal to undefined. Or if you read Hangul, I think this is like an H sound. Ha. Kind of. Sine of 180. Do we know sine of 180? Show me. Zettel. We can see it right there on my little mini unit circle. Secant of 0. Well, secant comes from the cosine, just like in D. So this is, in this case, it's a reciprocal of 1, which is 1. 270. Oh, this is negative 270. Where's negative 270? It's up top. So if I'm looking for cosecant, I'm going to take the reciprocal of the sine, the y value. That's why this is just equal to 1. Woo! That was a lot today. Would you please discuss with your neighbor what are the important things to remember for today. So what are the main takeaways? Radius of the unit circle is 1. That's huge. What else? What's that? The special triangles, they're huge. Those are very important. How many special triangles are there? Special right triangles? There's only 2 of them. Just make sure to put it in the right orientation. After that, what else is important? Exactly. Once you have your coordinates, the x coordinate is cosine, the y coordinate is sine, and you can get all the other 4 trig ratios from those 2. Did a great job today. Have a wonderful weekend. I'll see you on Tuesday. Do you have a quiz coming up or something? I feel like there's a quiz coming up.